Newton's second law does not roll off the tongue the way that Newton's first law does, which is why most people probably don't have it memorized. I'm going to read it. You ready? In English, the acceleration of an object is directly proportional to the net force applied to the object and inversely proportional to the object's mass. That's quite the mouthful. It's much easier to see in math. All right, so in math, A equals F over m. Acceleration equals force divided by mass. Sometimes written as F equals ma. I prefer the A equals F over m, and so do your reference tables in both Regents and AP. Now, what does this mean? It means that the harder you push something, the more it's going to accelerate. And the more mass it has, the less it's going to accelerate. And while that seems obvious, it's important to point out that some relationships are not direct. Okay? Acceleration is proportional to force. Push 3 times as hard, you'll get 3 times as much acceleration. Pull 10 times as hard, get 10 times as much acceleration. It's inversely proportional to mass. Something with 10 times the mass is 10 times harder to accelerate. You have to push it 10 times harder to get the same acceleration. So that is Newton's second law in a nutshell. Mass, as we just said in the previous video, is measured in kilograms. It is a scalar quantity. Force, however, is a vector. It's measured in kilograms times meters per second squared, which, to honor Sir Isaac Newton, we named the Newton. And of course, being a vector, that means that with forces, we have to take into account angles and directions. So everything we've learned about vectors and splitting them up into x and y components definitely matter with forces as well. You'll notice, of course, that this law mentions net force. Net force is like, if you're talking about a paycheck, your net pay versus your gross pay. Gross pay is the number of hours you've worked times your average salary. So you work 10 hours at $15 an hour, your gross pay is $150. But you don't get $150. We subtract your taxes and then other taxes and then additional taxes, also some taxes, and then some taxes. And once we've taken all those taxes out, you end up with however much you end up with, which is significantly less than $150. Same idea with forces. If I'm pulling something this way, and then I'm also pulling this way, some of that force is going to cancel out. And in fact, I'm sitting in a chair right now. Gravity is pulling down on me. I have the force of gravity on me, but I'm not falling. I also have the force pushing up on me, and those two things are perfectly canceling each other out, resulting in a net force of 0. So net, in this case, simply means total. You see on the AP Physics reference tables, they use the summation sign as well. So the sum of forces and the net force mean the same thing. In situations where the net force is 0, you're going to have no acceleration. This is known as equilibrium. Equilibrium, you've seen this word in other science classes. Equilibrium in general means balance. If the forces are balanced, that means that there is no total force, no net force, and you're not going to get any acceleration. So that's Newton's second law in a nutshell. Our next video, we're going to talk about the various types of forces and some of the equations and the math that go along with those forces. Following that, we'll talk about Newton's third law, and then we'll get into how to solve problems involving these mathematically. See you next time.